Okay, so we've covered imagining or visualizing magnetic field lines by sprinkling iron filings around the magnet. And if you ask me, I think it's pretty cool. So now we're going to learn how we can plot these experimentally in a lab, right? Is there a way to verify these magnetic field lines, right?
It's probably safe to say that you have a very good idea of how the magnetic field of a bar magnet looks like. But do you know the 4 important properties of magnetic field lines? To find out, let's begin by plotting some magnetic field lines. We need a pen, plotting compass, and a magnet. A magnet doesn't tell me which is the North Pole and which is the South, but we'll find out soon. Place your magnet in the middle of the page and trace around it. Place the plotting compass near the magnet. Mark the direction that the compass needle points by drawing a dot. After the first plot, move the compass so that the back of the needle lines up with the dot. Repeat this until you reach the end of the magnet. Join the points together to show a field line. I'll also draw an arrow here to show the direction that the needle is pointing in. I'll do all of the above again with another starting point. Looking at the field that we've plotted, we can figure out the 4 main properties of magnetic field lines. Number 1, magnetic field lines never cross each other, they never overlap. Number 2, they always point from the North Pole of the magnet to its South Pole. North into South, so that must mean that this is North and this is South. Number 3, they are continuous. The only reason these lines have been cropped out here is because I've simply run out of space. Number 4, where the lines are closer together, the magnetic force is the strongest, and that's at the poles of the magnets.
Okay, so these are the 4 very, very important properties of the magnet. And this is an experiment you're expected to be able to know how to do experimentally in the lab, okay? Okay, so by using a plotting compass, you can get that obviously south is attracted to the north of the the south of the compass is attracted to the north. So the north is always pointing away from the north, and so the field lines are always going from north to south. Okay, they never cross. It's always going north-south. It's continuous. And the closer the lines, the stronger the force, just like all the other fields that we've done. Okay? So just a recap of what that video said. Again, this will be, you have handout question 8. Okay, handout question 8 tells you draw 2 diagrams to illustrate how you would plot the magnetic field lines of a bar magnet using a compass, because you're expected to know experimentally how to do this. You see learning objective 5. Let's go up to learning objective 5. Says draw the magnetic field pattern around a bar. At 6. Describe the plotting field of magnetic field lines with a compass. Describe the, I think I probably typed wrongly. Describe plotting the field of magnetic field lines with a compass. Okay, so you're supposed to know how to do that. Okay, so please, as I go through the slides, answer this question after that. Okay, so magnetic field lines. Magnetic field pattern. So the first thing is you place the bar magnet at the center of the paper and align it in the north-south direction. It's a small detail, but it's kind of important because you don't want the Earth's magnetic field to be getting in the way with the magnet, right? So place the bar at the center of the paper, and then you trace the paper and show that the north is pointing to the Earth's North Pole. Okay, next you use a plotting compass, and then this is the next picture that is probably self-explanatory enough. So you plot dots, so you plot the compass, and then basically you place the compass at X and mark at the south and north ends of the compass needle, just like the video said. You move the compass to Y and you repeat the process of marking the points until the South Pole is reached, or basically you reach back the magnet again. Okay, join the dots with a single line. Repeat the process by starting from different points near the North Pole until several lines are drawn. It's basically everything that was said in the video. I'm just putting it down here in words in case you want to see the words. You can pause the video and take it down. It's also all in your textbook. Okay. So yeah, these will be the two images I will draw to illustrate what I'm saying. Okay. So after drawing everything, you see that, hey, my magnetic field pattern will look something like this. Okay, it will look something like this. This is what my magnetic field pattern will look like around a single bar magnet. And the key characteristics of the magnetic field, this is super important. If my sounds were working, you'll hear a boom here. Point outward from north towards south pole. So it points outwards from north towards south pole. Okay, they don't cross. And the closer the field lines represent the stronger the field lines, and vice versa. Okay, so vice versa means the further apart the weaker. Okay, everything that we've covered already. I think that should be relatively clear. All right, so magnetic field patterns between magnets, right? So what are the field patterns between different combination of magnets? So let's say so this one was just one magnet, right? But what if I have two poles, say a north and a south pole, right? Two unlike poles. It always goes from north to south, as you saw in the video. So you would draw north to south, and then it will be really, really strong in the middle. So everything will bunch up in the middle, right? And then they'll start to spread out as you go further and further away. It's continuous, so you start to get these round bits, okay? And then so on and so forth. Okay, but basically it keeps going from north to south. In the middle is a straight line, and then it'll start curving and curving and curving around. And even here, actually, they're supposed to be continuous. They don't end. Okay, so it actually, if you imagine, it actually forms a circle and comes back here. Okay, just that your paper is limited, so these lines will look like they end, but actually they don't end because they form a circle and come back here. Same as this one, it forms a circle and comes back here. But you're allowed to show some of them end. Okay. Some of them end they don't really end. So two like poles, what do you get? The field lines go from north to south. Since it's north pole, they will repel. The field lines don't ever cross each other. So when they reach here, they will be repelling each other. So they turn away. So here you will see a spot where there are no field lines. Okay, so here they repel like so. Okay, in this case, you have no choice but to cut them off. If you have a south pole, if your magnet has a south pole, then you can actually join some of them back to the south pole. Okay, but basically here is the part that matters. Okay, so if you're handout 1, you can go and try question 8 to 9 right now. Okay, so these are the two diagrams you're supposed to draw. You just go back to the lesson earlier and you can go and draw that. And then question 9, just pause the video here. Actually, I think you should be able to figure it out from the lesson, but I'm going to show you the answer. So just pause the video right now, go and try on your own. Please remember to use a pencil, and then you play the video and the answers will magically appear. Okay, I know I said all the answers will magically appear, but I thought I should go through the steps to drawing it with you. I think the single magnet one's easy, but this one, I don't know, some of you might not know what's the best order to draw it, so I'm going to go through this with you using these two examples. Okay, so for attraction, where there is north and south pole, I would draw the one in the middle first. I would use a ruler to draw a straight one in the middle, and it is going from north to south. Right? Remember, the compass needle will always point from north to south, so the direction is always north to south. Okay, I'll draw the one in the middle first, then I'll draw two close curves around it. Then I gradually open up the curves. And remember that when you meet, you should meet close. The starting point and the ending point should meet close to the previous field line drawn. Okay, why? Because this shows that the field strength is strong here and weak here, because they're far apart here and close together here. So that's quite an important detail. So you can go up high, but you should land close. That's why you should use a pencil to make small adjustments. Okay, this is probably enough. You can just show that you have more pointing out this way, more pointing out this way, and more coming in, more coming in. Okay, but remember, the field line should always start or end at a magnet. Okay, so this is for north to south, and then this one, if it's south and south, which one should you draw first? Again, I draw the one in the middle first. This one you don't start from the middle, because the middle, there's nothing right in the middle, so I'll start from here, somewhere around the halfway point, and then I'll bend away. Oops, it's a bit difficult to do on my tablet, which is slanted. Okay, so go upwards, same thing here, and then you go upwards. Okay, so I draw that first. Okay, this takes a bit of practice, so good thing that you have this practice. Okay, next one, as you go further away, no. Okay, so remember, start close to the fill line here, and then when you go up, it can be further away. Okay, so start close to the fill line here, and then go up, it can be further away. Same thing. Okay, what you need to be careful here, right, is that the fill lines, right, for these, right, shouldn't be drawn like this. Okay, let me just finish drawing this one first. Okay, I think this is about enough. You can just show that this curls away, and again, oh my gosh, all my directions are wrong. Okay, so sorry, all my directions are wrong. I hope somebody pointed it out. Right, so they should all be pointing towards south because it's north to south, right? So the fill lines are always pointing towards the south direction. Okay, so change all of that. Okay, yeah, I think I've changed all of them. Okay, so yes, I'm missing one here, so remember they should be pointing towards the south. So you have to be very careful. I also make careless mistakes, but just try to be super careful. Okay, so this is south, everything should be pointing towards south. Okay, sorry, I added a few unnecessary seconds to the video. What I want to highlight is that when you draw these ones, right, so I'm going to draw another example, right, so south, right, when you draw your fill lines, right, what you cannot do is draw them like that. Okay, you cannot draw them like that. Why? Because where do these magnets, fill lines don't end, right? So if they're continuous, where will this extend to if you had more space? They would cross to each other, right? So I mean, just to be very, very sure that you know what you're doing, try to really bend away and show that they're not going to meet for the center too. You know what I'm saying? So try not to have them draw them like this. I mean, try to make them curve away a bit. Okay? Yeah, that's all I'm going to say. So with that, this is what your fill line should look like. Sorry, a bit messy. Hopefully yours is neater than mine. Okay? And then that would bring us to the end of this lesson. We've learned what is a magnetic field. It's a region of space where a magnetic object experiences magnetic force. You can plot it, you know how to plot it and describe the process of plotting it with a compass, or plotting compass. And of course, how you can draw the magnetic field patterns of interacting magnets, okay, mainly attracting and repulsion and a single magnet. Okay, they don't always have to test you in this way. They could put, I don't know, north and north on top of each other, below each other, okay, but just turn your paper, okay, it's quite straightforward. Okay, so yeah, that's it for this. I'll see you in your next lesson in the next video.